Hello and welcome to another Math Studies video. I'm going to talk about the first application of the derivative, which is to find the slope of a curve at a point and to calculate the tangent line or normal line of a curve at a given point. So first of all, remember that if we have the following curve, here's example, I have several points in the curve, and these points A, B, C, and D are determined by the x value -1 and the f of -1, which in this case would be -2. B would be 0, f of 0. C would be 1, f of 1, and D would be 2, f of 2. So if I calculate the derivative of this function here, now remember how to do that, I'm going to get this, 3x squared minus 2x minus 1. And if I substitute here, it's going to be very important, if I substitute here with the x value of -1, I'm going to get the slope at point A. That is the slope exactly here. If I drew a line here, what is the slope of that line? If I drew a tangent line to A, what is the point of that line? Now, simply substituting here, I'm going to be getting 4. I substitute in the derivative, I put -1 in the derivative, and I get 4. So that is simply the slope at point A. And I can similarly calculate the slopes at point B, C, and D. -1, 0, and 7. It makes sense it's 0, right? Because there's no slope here. So the derivative gives us the exact value of the slope at a given point, of the slope of a function, in this case f of x. With a graphic display calculator I can do this, and I'm going to do this with an unusual example, which is a function that is totally out of the scope of mathematical studies, but it's a good example because you don't have to know what this function even looks like to calculate this with a graphic display calculator. So the first thing to do is to insert the function. You press Y and type in the function. Just make sure you type it correctly. The next thing is to get out of there and go back to the general screen. Click Math and scroll down to NDeriv. It's option number 8 in the Math menu. And you're going to end up with this when you press Enter. So make sure you put this x here. It just tells the calculator what variable are you making the derivative of. And it's going to be variable x. Maybe if you have a function in terms of t, you might want to put a t here, but that's very unlikely. Just stick to the x. Now I go to, what do I insert here? And rather than having to type this all over again, I can just go to vars and I go to function. If I enter here, I can enter y1, which is where I put the function in the first place. I put the required value for x. I'm going to put x equals 1. And I'm going to get the value of the derivative there. It just calculated it for me. I didn't have to do that much, did I? I can also calculate for x equals pi and for x equals -1. It's very easy to get results here. But what I'm not getting, and this is important, what I'm not getting is I'm not getting the derivative of this thing. I'm not getting an expression in terms of x of the derivative of this thing here. Keep that in mind. I can calculate for given values, but I cannot get an expression of x for the derivative, which is why I still need to know how to calculate derivatives. So let's go to the next thing, which is the tangent line. Let's first revise what a tangent line is. So I have a function, here it is, and I have points in the function. I can draw the tangents to those points in the function. Here they are. The blue line is the tangent at A, the green one the tangent at B, the red one the tangent at C, and the purple one the tangent at D. So some things about tangent lines. Remember, the tangent line touches the curve at one point only. That's not perfectly true. Look at the green line here. It also touches at C. But the important thing is that in the vicinity of B, it only touches at B, nowhere else. Second thing, there's only one possible tangent line. And finally, it's a line, right? So if it's a line, the equation of the line is going to look like this. We've seen hundreds of these before, right? Great. So m is the slope of the line, and of course I'm going to calculate the slope of the line is going to be the slope of the curve at this point. It's going to be the same one, so I'm going to use the derivative for that. And then we'll do a little trick to calculate the c. Just walk through it. This is a typical exam exercise. So for the m, we get the derivative, and then we'll do c. Know how to do this. So f of x at a point A. Let's calculate the tangent line. So we know that this is the function, and that this is the point A. How do I calculate the tangent line? Well, it's going to have this form, and the m is going to be the slope. So I calculate f prime of x. Here it is. I substitute the f prime of -1. So in here, I put -1, and I end up that f prime is equal to 4. So simply, m is equal to 4. Very easy, not that complicated. Now, if they ask me for the normal, which is the one that's perpendicular to the tangent, all I have to do here is change this and put minus 1 over 4. If they ask me for the normal or the perpendicular line, that's how you do it. Finally, I have the m, I'm missing the c. Let's calculate the c. So here I have this. Now, of course, since I already know that it goes through a point, I know it goes through point A, I just have to use the coordinates of point A. Now let's make sure we know how to calculate the coordinates of this point here. All I have to do is take my function, and where I have the x, put minus 1. And I'm going to end up with the coordinates of the point, minus 1, minus 2. I can see them here, but it's good to calculate it, just to be 100% sure. Because it might look like it's minus 2, but maybe it's minus 1.98, and we could have it wrong. Just make sure and actually calculate it. Now we have the coordinates of a point of the line. We substitute in the line equation to calculate the c. So I take this line equation, and where I have y, I'm going to put minus 2. Where I have x, I'm going to put minus 1. And this is what it's going to look like. Now when I clear this equation up, I'm going to end up that c is equal to 2. And hence I have the equation of the line tangent to f of x at point A, which is y equals 4x plus 2. This is such a classic question in the exam that I need you all to be able to do this. And let's revise exactly the process we just went through. Summary of the process. We have f of x, we need to calculate the equation of the tangent or perhaps normal at point A. So we calculate the f prime. We substitute with the x coordinate of point A in the derivative, and we get the slope. If they're asking us for the normal, make sure that you put minus 1 on whatever you get. Okay. Now you calculate the y coordinate at that point, and you substitute in the line equation, and that's how you calculate the value of c. Now you can try, just for practice right now if you want, calculating the equation of the tangent to f of x at points b, c, and d that we had before. Here's f of x again for your reference. These are the points, and here are the graphs. And the actual equations are going to be, for the tangent at point b, this is going to be the equation. For the tangent at point D, this is going to be the equation, and for the tangent at point C, this is going to be the equation. Now, important to realize that what's actually happened here is that m has given me 0, and 0 times x is 0, so I'm only left with the c. Thank you very much for watching. This is actually a very important one. Sorry the video was a bit too long. I hope it wasn't too bad. See you next time. Goodbye.